For centuries, the moon has mesmerized scientists, artists, and poets alike. Moon landings hold immense significance in the history of astrophysics and astronomy. From 1963 to 1972, there were a total number of 6 successful moon landings attributed to the Apollo program. The first one, renowned as Apollo 11, was a major breakthrough for humankind. On July 20, 1969, American astronauts Neil Armstrong and Edwin Buzz Aldrin were the first humans ever to land on the moon. About 6.5 hours later, Armstrong became the first person to walk on the moon. However, unfortunately, the actual moon landing tapes were said to have been removed. NASA chiefs just revealed the truth about what happened to the original moon landing tapes. In today's video, we'll find out what really happened and how such a credible institute made such a blunder. As he took his first step, Armstrong famously said, "That's one small step for man, one giant leap for mankind." The Apollo 11 mission took place 8 years after President John F. Kennedy declared a national goal to land a man on the moon by the end of the 1960s. The final human-crewed moon mission, Apollo 17, took place in 1972. President Kennedy's appeal to a special joint session of Congress on May 25, 1961, served as the impetus for the American effort to send astronauts to the moon. Kennedy's audacious suggestion was warmly received in Cold War-era America because at the time, the United States still lagged behind the Soviet Union in space development. 5 years after a global team of scientists and engineers began their work, the first unmanned Apollo mission, which tested the mechanical strength of the proposed launch vehicle and spacecraft combination, was carried out by NASA in 1966. Then, tragedy struck at the Kennedy Space Center in Cape Canaveral, Florida on January 27, 1967, when a fire erupted during a manned Apollo spacecraft and Saturn rocket launch pad test. The fire claimed the lives of 3 astronauts. Despite the setback, NASA and its thousands of staff members continued to strive for their mission. In October 1968, Apollo 7, the first manned Apollo mission, orbited the Earth and successfully tested a number of the complex systems required to conduct a moon journey and landing. Apollo 8 carried 3 astronauts to the far side of the moon and back in December of the same year, and Apollo 9 conducted the first lunar module test while orbiting the Earth in March of the following year, 1969. That May, 3 Apollo 10 astronauts flew the first complete Apollo spacecraft around the moon in preparation for the July landing mission. On July 16th at 9:32 a.m. Eastern Standard Time, Apollo 11 lifted off from the Kennedy Space Center with astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins aboard. The mission was led by Armstrong, a 38-year-old civilian research pilot. On July 19th, Apollo 11 entered lunar orbit after traveling 240,000 miles in 76 hours. The next day at 1:46 p.m., Armstrong and Aldrin's lunar module, Eagle, split from the command module where Collins stayed. The Eagle started its takeoff to the lunar surface 2 hours later, and at 4:17 p.m., the craft landed on the southwestern edge of the Sea of Tranquility. Armstrong immediately radioed Mission Control in Houston, Texas, with the now famous message, "The Eagle has landed." Armstrong opened the lunar module's hatch at 10:39 p.m., 5 hours earlier than planned. A television camera mounted on the craft captured his ascent down the module's ladder and transmitted the signal back to Earth, where hundreds of millions of people eagerly watched. Armstrong then uttered his famous quote at 10:56 p.m. as he descended the ladder and landed on the moon's dusty surface, which we discussed earlier. 19 minutes later, Aldrin arrived on the moon's surface with him. They took pictures of the terrain, planted a flag for the United States to honor the fallen Apollo 1 crew, conducted a few simple scientific experiments, and talked to President Richard Nixon via Houston. A short time after Armstrong and Aldrin planted the American flag on the lunar surface, President Richard Nixon communicated with them over a telephone radio transmission. According to Nixon, it was the most historic phone call ever made from the White House. The hatch was closed and both astronauts were inside the lunar module by 1:11 a.m. on July 21st. That night, the 2 astronauts slept on the moon's surface, and at 1:54 p.m. the Eagle started its hike back to the command module. Besides the American flag, one of the things left on the moon's surface was a plaque that said, "Here men from the planet Earth first set foot on the moon, July 1969 AD. We came in peace for all mankind." Armstrong and Aldrin successfully docked and reunited with Collins at 5:35 p.m. On July 22nd, Apollo 11 started its return trip at 12:56 a.m., safely splashing down in the Pacific Ocean on July 24th at 12:50 p.m. Although mission Apollo 11 was a massive victory for NASA, its staff, and the astronauts on board, in 2006, NASA admitted that the original moon landing tapes had been erased and were nowhere to be found. This mishap gained notoriety as the Apollo 11 missing tapes. The Apollo 11 missing tapes were recordings from the slow-scan television SSTV telecast of Apollo 11 in its raw format on telemetry data tape made during the first moon landing in 1969, and then they were lost. For backup, data tapes were used to document all transmitted data, video, and telemetry. NASA ground receiving stations carried out real-time scan conversion to the NTSC television format in order to broadcast the SSTV transmission on regular television. On July 21, 1969, a converted video signal of the moonwalk was live broadcast all over the world. The NTSC broadcast at the time was captured on numerous videotapes and kinescope films. These poor-quality recordings frequently are still intact. The backup video was not prioritized for preservation in the years right after the mission because the real-time broadcast was successful and widely recorded. The tapes were probably erased and reused at this time because NASA's Landsat program was experiencing a severe data tape shortage in the early 1980s. In the early 2000s, a team of retired NASA employees and contractors looked for the tapes but were unsuccessful. A number of still images that showed the visually superior raw SSTV transmission on ground station monitors in the late 1990s ignited the search. The quest for the moonwalk's clearest and most accurate video recordings took the research team several years. If duplicates of the original SSTV format tapes could be located, more advanced digital technology could perform a higher quality conversion, producing images that were superior to those originally seen. The researchers came to the conclusion that NASA erased and reused the tapes containing the raw, unprocessed Apollo 11 SSTV signal in the early 1980s in accordance with the accepted practice at the time. Even though the telemetry tapes were never found, the researchers did locate the finest NTSC videotapes and a Super 8 film shot of an Australian video monitor that captured the SSTV transmission before it was converted. These visual components were altered in 2009 as part of the first moonwalk restoration project approved by NASA. The investigation team revealed its conclusions regarding the disappearance of the tapes at a news conference in Washington, D.C. in 2009. They also released some of the newly improved videos that were found during the search. In late 2009, Lowry Digital finished the entire moonwalk restoration project. The video signal from the lunar landings had to be multiplexed with other communication. Due to the limited radio bandwidth, telemetry channels beam from the lunar module Eagle back to Earth. As a result, the Apollo 11's moonwalk video was broadcast from the Apollo TV camera in a monochrome SSTV format at 10 frames per second with 320 lines of resolution gradually scanned. Radio telescopes at the Goldstone Tracking Station in California, the Honeysuckle Creek Tracking Station in Australia, and Parkes Observatory in Australia picked up these SSTV signals. But the camera's video format was incompatible with current broadcast television standards for NTSC, PAL, and CCAM. Before it could be aired on broadcast television networks, it needed to be converted. This crude live conversion essentially involved pointing a video camera at a premium 10-inch TV monitor. Real-time scan conversion was required in order to display the camera's images on a standard TV set because the camera's scan rate was much lower than the approximately 30 frames per second for NTSC video, the television standard in use at the time in North America. NASA chose an RCA scan converter to convert the black and white SSTV signals from the Apollo 7, 8, 9, and 11 missions. The ground stations received the SSTV signal from the Apollo TV camera when it radioed its images in their raw, unconverted form and divided it into two branches. Unprocessed data from one signal branch was recorded at 120 inches per second onto 14-inch diameter reels of 1-inch wide analog magnetic data tapes using a 14-track analog data tape recorder. The RCA scan converter transformed the other raw SSTV signal branch into an NTSC broadcast television signal. The RCA scan converter used an optical conversion method of operation. The signal was sent to a top-notch 10-inch video monitor, where it underwent conversion instead of simply being rephotographed by a traditional RCA TK22 television camera using the NTSC broadcast standard 525 scanned lines interlaced at 30 frames per second. Persistent phosphors on the monitor served as a simple frame buffer. The first field from the camera was recorded on a disc recorder based on the Ampex HS100 model. The NTSC field interlace switch or encoder was fed that field and a properly time-delayed copy of the first field. The first complete 525-line interlaced frame was created by combining the original and copied areas. The signal was then sent to Houston. Until the camera captured the subsequent SSTV frame, the disc recorder iterated this sequence 5 more times. The converter then went through the entire process again for each new frame live downloaded from space. The extra 20 frames per second required by television broadcasters around the world to deliver flicker-free images were thus produced by the RCA converter. Compared to the early 21st century electronic digital conversion methods, this live conversion was primitive. With this system, image degradation was inevitable because the monitors and the camera's optical capabilities significantly reduced the original SSTV signal's contrast, brightness, and resolution. The image could be severely harmed if the scan converter's settings were incorrect, as they were at the Goldstone station during the first few minutes of Apollo 11's moonwalk. Armstrong could hardly be seen when he first descended the ladder of the lunar module because the scan converter operator had incorrectly set the contrast and vertical phase. The extremely long and noisy analog transmission path further harmed the quality of the video seen on home television sets. Houston received the converted signal via satellite from the 3 receiving ground stations. The network pool feed was then transmitted live to America and the rest of the world from New York via microwave relay. These links all added noise and distortion to the signal because they were all analog. It was common practice to record the Apollo 11 moonwalk in real time onto kinescope film and NTSC broadcast quality 2-inch quadruplex videotape. These low-quality optical conversions of the video images were created with a TV camera taking pictures of a video monitor. The public has had access to recordings of this conversion for a long time, along with much higher quality video from later Apollo missions. Modern digital technology would enable significantly better conversion and processing if the 1-inch data tapes containing the raw, unprocessed Apollo 11 SSTV signals were to be discovered. The quality would be comparable to what a select group of technicians and others at ground stations that could receive SSTV saw before the video was changed to NTSC. An amateur Super 8 film with roughly 15 minutes of images from Apollo 11 was rediscovered in 2005. Ed von Renoir recorded the footage at the Honeysuckle Creek tracking facility during or after the Apollo 11 moonwalk. The images primarily depict a scan-converted monitor with a brief appearance of a slow-scan monitor. These are some of the best recordings of the Apollo 11 moonwalk. The photos are available on DVD. On August 5, 2006, the Sydney Morning Herald published an article titled "One Giant Blunder for Mankind: How NASA Lost Moon Pictures," which revealed the existence of these analog data tapes as missing. The tapes were among the 700 boxes of magnetic data tapes recorded during the Apollo program that was never found. According to a statement released by NASA on August 16, 2006, the original tapes may be at the Goddard Space Flight Center or another location within the NASA archiving system. It further stated, NASA engineers are hopeful that when the tapes are found, they can use today's digital technology to provide a version of the moonwalk that is much better quality than what we have today. As the Constellation program shared some responsibilities with the initial Apollo program, NASA also had ongoing research motives for discovering these higher resolution tapes. Some were concerned that even if the tapes were later discovered, there would be no ready way to read and copy them. This is because the only known surviving piece of equipment that could read the missing videos was located in the Goddard Center's Data Evaluation Laboratory, which was scheduled to close in October 2006. However, tools for reading the tapes were kept up. In a small marine science lab in the main physics building at Curtin University in Perth, Western Australia, some NASA telemetry tapes from the Apollo project era had been discovered, according to a November 1, 2006 article in Cosmos magazine. NASA received one of these tapes for review. Although it didn't contain any video, it did demonstrate that data could probably be read from the tapes if they were ever discovered. On July 6, 2019, Sotheby's announced that 3 2-inch videotape reels out of a total of 1,150 reels purchased at a government surplus auction in 1976 for $218 would be put up for sale on July 20th. The 3 reels were not the missing 1-inch telemetry data tapes, despite claims that they were first-generation recordings of the Apollo 11 EVA video. Gary George, a 1976 Lamar University engineering student, had bought the tapes at a General Services Administration auction. While working as an intern at the Johnson Space Center, George learned about these government surplus auctions. The 3 tapes were sold to an undisclosed buyer for $1.82 million on July 20, 2019, the 50th anniversary of the first moonwalk, according to Sotheby's. Despite Sotheby's claims that those tapes were the best surviving NASA videotape recordings of the historic Apollo 11 moon landing and the earliest, sharpest, most accurate surviving video images of man's first steps on the moon, NASA claimed that they contain no material that hasn't been preserved at NASA. On July 16, 2009, the 40th anniversary of Apollo 11's launch from Cape Kennedy, NASA held a press conference at the Museum in Washington, D.C. regarding the missing tapes. Richard Navsger from the Goddard Space Flight Center and Stanley Labar, the former lead engineer at Westinghouse who created the Apollo lunar camera and the Apollo color camera, represented the international research team at the event. The team primarily comprised retired engineers who worked on the original broadcast in 1969. They concluded that the data tapes, which contained the SSTV signal, were shipped from Australia to Goddard, where they were subsequently regularly erased and reused a few years later. After Goddard received the reels, backup tapes from Australia were also deleted per the guidelines laid out by NASA. The SSTV signal was primarily recorded on telemetry data tapes to have a backup in case the real-time conversion and global broadcast failed. The backup video was not considered significant because the real-time broadcast conversion was successful and was widely documented on film and videotape. NASA's Landsat program experienced a severe data tape shortage in the early 1980s, and the tapes were likely erased and reused during this time. There was also proof that the Parkes Australia facility used modified Ampex 2-inch helical scan VTRs to record the Apollo 11 moonwalk SSTV. The Applied Physics Labs at Johns Hopkins University modified the VTRs to record 320-line slow scan video without conversion directly to the videotape. These tapes were undoubtedly delivered to Johns Hopkins University, but the search team could not locate them. According to Navsgar, the team discovered several post-conversion copies of the broadcast that were higher quality than the general public had previously seen. Their research included a videotape shot in Sydney shortly after the conversion but before it was broadcast globally via satellite, a videotape from the CBS News archives that was received directly from NASA without any commentary, and kinescopes from the Johnson Space Center. It was mentioned at the press conference that Lowry Digital would finish editing and restoring the tapes. Lowry Digital's president stated that his company would only fix the video and leave any flaws like reflections that looked like flagpoles in place. A few brief clips were played at the news conference to illustrate their improved quality. After the news conference, NASA posted some partially restored samples on its website. The roughly 3-hour-long footage underwent a complete restoration that was finished in December 2009. John Sarkissian's efforts led to the discovery of additional footage from Australian ground station feeds depicting SSTV video of Armstrong's descent and first steps. The public first saw portions of this fully enhanced video on October 6, 2010, at the Australian Geographic Society Awards, where Buzz Aldrin was the special guest. There are plenty of reasons to return people to Earth's giant dusty satellite and stay there more than 45 years after the most recent crewed moon landing, Apollo 17, in December 1972. Former Vice President Mike Pence promised that the United States will have astronauts on the moon by 2024, including the first woman to set foot on the lunar surface as part of a program called Artemis. NASA Administrator Jim Bridenstine stated that the ambitious goal would necessitate significantly more federal funding, which has historically been a political sticking point in Washington. "We would be on the moon right now if it weren't for the political risk," Bridenstine said. "In fact, we'd most likely be on Mars." The high cost of any spaceflight program, particularly missions involving people, is a tried-and-true roadblock. NASA's budget for 2019 was $21.5 billion, and the Trump administration asked Congress to increase it to $22.6 billion in the 2020 budget. Those sums may appear to be a windfall until you consider that they are divided among all of the agency's divisions and ambitious projects, including the James Webb Space Telescope, the Space Launch System, and far-flung missions to the Sun, Jupiter, Mars, the asteroid belt, the Kuiper belt, and the edge of the solar system. In comparison, the US military budget is around $680 billion annually. Furthermore, NASA's budget is relatively small in comparison to its past. According to a NASA report from 2005, returning to the moon would cost about $104 billion, or $133 billion today, with inflation spread over nearly 13 years. In today's dollars, the Apollo program cost around $120 billion. Crewed exploration is the most pricey space venture, and thus the most difficult to obtain political support for. The Bush administration tasked NASA in 2004 with developing a plan to replace the space shuttle, which was set to retire and return to the moon. The agency devised the Constellation program to land astronauts on the moon using an Ares rocket and an Orion spaceship. Over 5 years, NASA spent $9 billion designing, building, and testing hardware for that human spaceflight program. However, the will of the American people who elect politicians and influence their policy priorities is the real motivating factor behind the government's commitment to sending astronauts back to the moon. But the general public has never shown much interest in lunar exploration. Only 53% of Americans believe the Apollo program was worthwhile even at its height when astronauts Buzz Aldrin and Neil Armstrong first set foot on the moon. The majority of the time, Apollo received less than 50% of US approval. Most Americans today believe that NASA should prioritize going back to the moon. More than 57% of respondents from across the country to a poll in December 2018 said that NASA should emphasize going back to the moon, but only about 38% said that it's necessary for living, breathing humans to do so. Others who support the US moon landing claim that robots could carry out lunar exploration. However, a 2018 Pew Research Center poll found that 63% of respondents agreed that crewed Mars exploration should be a NASA priority. This indicates that support for this goal is growing. 91% of people believe it's crucial to search the skies for deadly asteroids. Ultimately, people haven't revisited the moon for several reasons, including the political struggle of NASA's mission, budget, and the fact that the moon is a 4.5 billion-year-old death trap for humans is not to be taken lightly or undervalued. Craters and boulders cover its surface, endangering safe landings. In today's dollars, the US government invested a sum that would amount to billions to develop, launch, and deliver satellites to the moon to map its surface and assist mission planners in scouting out potential Apollo landing sites before the first moon landing in 1969. And a greater concern is what eons of meteorite impacts have produced, regolith or moon dust. According to Madhu Thangavelu, an aeronautical engineer at the University of Southern California, the moon is covered in a fine talc-like top layer of lunar dust, several inches deep in some regions, which is electrostatically charged through interaction with the solar wind and is very abrasive and clingy, fouling up spacesuits, vehicles, and systems very quickly. Peggy Whitson, an astronaut who spent 665 days in space, previously stated that the Apollo missions had a lot of problems with dust. If we're going to spend long periods of time and build permanent habitats, we've got to figure out how to deal with that, Whitson said. There's also the issue of sunlight. The lunar surface is a boiling hellscape exposed directly to the sun's harsh rays for about 14 days at a time, and the moon has no protective atmosphere. The moon's surface will be one of the coldest places in the universe for the next 14 days due to total darkness. NASA's Kilo Power Small Nuclear Reactor could provide electricity to astronauts during weeks-long lunar nights and would be helpful on other worlds, including Mars. Thangavelu wrote, "There is no more environmentally unforgiving or harsher place to live than the Moon. However, because it is so close to Earth, there is no better place to learn how to live away from planet Earth." NASA has developed dust and sun-resistant spacesuits and rovers, but it's unclear whether they're ready for launch. Another issue, according to astronauts, is NASA's graying workforce. Today, more American children polled say they want to be YouTube stars rather than astronauts. The average age of the people in mission control for Apollo 13 was 26 years old, and they'd already been on a bunch of missions, said Apollo 17 astronaut Harrison Schmitt, expressing concerns, noting that the average age at NASA's Johnson Space Center today is closer to 60 years old. The desire of many astronauts to return to the Moon aligns with Jeff Bezos' long-term vision. Bezos has proposed using Blue Origin's upcoming New Glenn rocket system to construct the first moon base. Elon Musk has also spoken extensively about how SpaceX's upcoming Starship launch system could pave the way for regular low-cost lunar visits. SpaceX may even be the first company to visit the Moon before NASA or Blue Origin.